All right, so we are going to be doing section 7.5, which is similarity, perimeter, and area ratios today. So our first is a measurement application. So these are really similar or really popular types of problems for whenever you have similarity because they like to measure big things to little things. So first, Tyler wants to find the height of a telephone pole. He measures the pole shadow and his own shadow and then made a diagram. What is the height h of the pole? So if you look at the picture, we can't necessarily prove or we can't see from the picture that the triangles are similar, but we do know that they have that right angle in common right here. And so some of you may say, well, how the heck do we know if they're actually similar? And the answer to that is that if you have a cute little sunshine up here, yay, sunshine, the angle that the sunshine hits the telephone pole and the angle that the sunshine hits Tyler is going to make the same angle. So because of that, we know we have a similarity for these triangles. So the steps say to set up a proportion first and then to convert and solve. Personally, I would convert first. That way I already have the new measurements. So when you have 5 feet 9 inches, technically you could convert that to a decimal and it'd be okay. But the issue you run into sometimes is if you have like 5 feet 4 inches, then you're going to have 5.33 repeating. And then you might have some issues when you round and get your answer. So it's better, and this is just my personal preference, to convert it to just all inches. That way it's all in the same unit, and then go back and convert it back to feet at the end. So with 5 feet, you're just going to multiply your feet by 12. Oopsie, pushing things on the screen. So 5 feet is actually 60 inches. Plus the 9 would mean that Tyler is 69 inches tall. This 7 feet is 84 inches. So when you add in that extra 8 inches, it is 92 inches long of a shadow. And then for our telephone pole, 38 feet 4 inches is 460 inches. So now that we have them all converted, then we can set up the proportion. So personally, I would probably do 69 over 92 equals h over 460. Notice that my corresponding pieces of 69 and h are in the same spot, opposite sides. You could also have them on the same side, and then your 92 would just be where your h would go instead. But we'll get rid of that. So once you set up your proportion, you have to cross multiply, which would give you 92h equals 31,740. And then when you divide by 92, you get that h equals 345 inches. Now, because our original stuff was given to us in feet and inches, we want to still use feet and inches. So to convert this, we're going to divide by 12. And 345 divided by 12 is 28.75. Now, if you don't know how to make that 7.5 into inches, you know you have 28 feet total. If you take that 28 times 12, you get 336 inches. And so if you find the difference between those, you find that it is actually 9, which means that it would be 9 inches. So when you're converting, just be careful that you are multiplying by 12 to make it into inches and then dividing by 12 at the end, and then just make sure you find the difference if you're going to have a decimal, or just know how to convert the decimal into twelfths. So we know that the height for that telephone pole would be 28 feet 9 inches. So this next example is extremely similar, just a different person. So we have Maria is 4 feet 2 inches tall. To find the height of the flagpole, she measured her shadow and the pole's shadow. And what is the height h of the flagpole? So we're going to do the same thing. We're just going to convert everything to inches to make our lives a little bit easier. So 20 feet is 240 inches. 4 feet 2 inches would be 48 inches plus 2, which gives me 50 inches. And then 3 feet 4 inches becomes 40 inches. So then To find our height, you just have to set up a proportion. We know these triangles are similar because, again, the sun will hit them at the same angle. So, setting it up, you have a bunch of options, but we'll set it up this time. H over 240 equals 50 over 40. If you chose to set it up a different way, it would be okay as long as 40 was still getting multiplied to the H and 50 was getting multiplied to 240. So that would give us 40H equals 12,000. And then to solve this, we have to divide by 40 to undo that division or that multiplication. So then we have H equals 300 inches. Now, even though it's tempting to stop there, remember we have to convert it back to feet. So we'll just divide 300 by 12, and that'll give us that our height of the flagpole is 25 feet even. Now, a really quick, easy way that you can check yourself is to just plug in your value that you had for inches. We had that it was 300 inches. So if I do 300 divided by 240 and set it equal to 50 over 40, when I cross multiply, I get that 12,000 equals 12,000. So then I know that I did this correctly. So the next part to this is understanding how the similarity ratio compares to the perimeter ratios and the area ratio of similar shapes. So we were given that triangle ABC is similar to triangle DEF, and we were also given all the side lengths. So first, to get the similarity ratio, they tell us they want AB over DE. So AB is 5 and DE is 10. So 5 over 10 would simplify to 1/2. And that would be our actual similarity ratio. So then, if we're going to compare this to perimeter, we'll have to find the perimeter of triangle ABC and DEF. So for triangle ABC, let's see if it'll let me, there we go. We'd have 5 plus 4, which is 9, plus 3 is 12. And then for our perimeter for our big one, we have 10 plus 8 is 18, plus 6 is 24. So my area of ABC was 12 over the area of DEF was 24. And notice that also simplifies to 1/2. The ratio for your perimeter is going to be the same as your similarity ratio. Okay, and then last but not least, if we look at the area of these shapes, we're going to have to find the actual area of ABC. So we have 1/2 times our base of 3 times our height of 4. So that'd be 1/2 times 12, which gives us an area of 6. And if we do the area of our big triangle, we have 1/2 times our base of 6 times our height of 8. And then 1/2 times 48, gives me 24. So setting up the ratio for areas, we would have 6 over 24, which would simplify to 1/4. If you notice, it does not match the other ones. The area ratio is actually going to be your similarity ratio times itself, or the similarity ratio squared. So similarity ratio squared. And notice 1/2 times 1/2 is 1/4. So that just kind of proves it to you. Okay, so similarity ratio will be the same as your perimeter ratio, and your area ratio will be that similarity ratio squared. So we are given that triangle LMN is similar to triangle QRS, and we want to find the perimeter P and area A of triangle QRS. And we are told to round our answers to the nearest hundredth. So starting with perimeter, we want to get that similarity ratio, and we can get that by the side lengths. They should always give you at least one of the side lengths for each shape. So that would give us 9.1 over 13 equals, and 9.1 was a part of my small one. I don't know what my perimeter is, and I don't know what my area is yet. So rather than putting X to keep it straight, I'm going to just put a P. And then the perimeter of my big one was 36 centimeters. Okay, so then I'm going to cross multiply. I'll get 13P equals, let's see, where's my notes go? 327.6. And then when you divide by 13, you get that P equals 25.2 centimeters. Now, for area, remember the ratio for area is going to be that similarity ratio squared. So you want to be careful that you don't just put the similarity ratio. Some of you may prefer to square them before you actually write it into the proportion. It's kind of up to you, but I'm just going to write it here now just so that you can see the difference. So we started with the small one, so we'd have A on the top and then over 60. So then 9.1 squared is 82.81 and 13 squared is 169. So I'd have that over or equal to A over 60. So then when we cross multiply, 60 times 82.81 is 4,968.6. And then you have equal to 169A. And then when you divide by 169, we get that the area is 29.4 centimeters squared. So it may be easier for some people just to remember that your area ratio is squared. Remember that the unit for area is also squared. So if you ever forget, just remember your unit for area is squared, your ratio for area is going to be squared as well. Okay, so, oh wait, I did not round right because they asked for the nearest hundredth. I did not even notice that. Bad me. So if I actually rounded it the way they asked me to, area is 29.4 even. So nearest hundredth, you could put 29.40. And then for perimeter, just to double check, let's see, also 25.2 even. So it is technically rounded to nearest hundredth, we just didn't write the 0. So our next one, we have triangle ABC is similar to triangle DEF. So find the perimeter P and the area A of triangle ABC. So if you want, you can pause the video and try and do this real quick on yourself just by looking at the previous example. But in order to do this, we'll go back to orange for perimeter. That'll be nice. Oh, come on. Unless this wants to cooperate. So again, for perimeter, you're just going to use your side lengths to help you set up that similarity ratio. So we have 6.5 over 13 equals, again, we don't know our perimeter for our little one, and we don't know the area for the little one. So because I don't know the perimeter, I'm just going to put a P over my perimeter of 54. So then I'm going to cross multiply. You get 13P equals 351. And then when you divide by 13, you get that P equals 27 inches. Okay, now for area, you're going to do the exact same thing, except remember, you have to square that similarity ratio. Otherwise, you're not going to be doing it right. Again, we don't know what our area is, but we do know that the big one is 126, so we'll set it up like that. Before I cross multiply, I need to actually square my ratio. So that'd give me 42.25 over 169 equals A over 126. And then I can cross multiply, which would give me 5,323.5 equal to 169A. And then to solve that, of course, we divide by 169, so we get that the area is 31.5 inches squared. And then that is the end of that. So hopefully you're getting the hang of setting up these proportions and everything. So one more with area and perimeter. Same thing. Even if it's not a triangle, it's still going to be the same proportions for your area and for your perimeter. So again, if you think you're ready, pause the video, see if you can do it, and then go through the video and see if you match up with what I did. So Setting this up, again, perimeter, it's going to be the same. We're going to use these side lengths to help us. So I'm going to have 10 over 15. And again, I started with the small, so now I'm going to have my known perimeter 28 on the top over P instead. Again, if your perimeter or if your proportions set up differently, that's okay, just as long as you have 10 times P is equal to 420. And then to solve, we just divide by 10, and we get that P is 42 millimeters, our perimeter. Okay, and then for area, again, remember, we have to square this similarity ratio. If you don't, you didn't do it right. So we have 10 over 15 squared equals 40 over A. 10 squared is 100. 15 squared is 225. And then we just cross multiply. So that would give us 100A equals 9,000. And then when we divide by 100, boop, A is just 90 millimeters squared. Okay, and you can even do that without a calculator. Just cancel out those zeros. Boop. All right, and if you really want to check yourself, you can just plug it back into the proportion. When you plug in 90 where the A is, you'll still end up getting that 9,000 equals 9,000. So now we just got some this is our quick fire. They give us a side ratio of 3/5. So if our side ratio is 3/5, remember, that's going to be the same as perimeter. So then the ratio of my perimeter is 3 over 5. And then for my area, it's 3/5 squared. Well, 3 squared is 9. 5 squared is 25. So the ratio of our areas, would be 9 over 25. Let's see. I want to make sure it actually works for me. So then the next one, they tell us our area ratio is 25 over 49. So since similarity to area is squaring, to go from area to similarity, we're going to take the square root. So the square root of 25 is 5, and the square root of 49 is 7. So then I know my side lengths has a ratio of 5/7, and my perimeter also has a side ratio, my perimeters have a ratio of 5/7 as well. Next one, we have two similar figures with a side ratio of 3x over y squared, and we need to find our perimeter and area. Again, side ratio is going to be exactly the same as the perimeter ratio, so we'd have 3x over y squared. Now the ratio for the areas, I have to square both of my terms. So 3x squared becomes 9x squared, and then y squared squared becomes y to the 4th, because we had two y's and then we had to multiply them by themselves. Okay. Last but not least, we have our lovely side ratio of 54y squared over 3x squared. And so for me, I noticed that 54 looks like it might be divided by 3. If you add up the digits, 54, 5 plus 4 is 9, and 9 can be divided by 3, which tells me 54 can be divided by 3. And 54 divided by 3 is, I believe, 18. Let me see if yep, 18. So then instead of having 54y squared, I'd have 18y squared over x squared. Again, I just divided them both by 3. So then that would be my ratio for my perimeters, because that is always going to be the same as the ratio of your sides. And then the ratio of my areas would be this lovely thing squared. And so if I have to square that, 18 times 18 is 324. And that would be y to the 4th over x to the 4th. Just like that. Okay. So then, last short little bit, we have that a blank blank, and in the blank, it is a scale drawing represents an object as smaller or larger than its actual size. The drawing scale is the ratio of any length in the drawing to the corresponding actual length. For example, on a map with a scale of 1 to 1500, 1 centimeter on the map represents 1500 meters in actual distance. So you're going to have problems where you have to convert you're going to have a ratio that you're going to have to work with. So we have a blueprint for Trina's bedroom uses a scale of 1 inch to 4 feet. Her bedroom on the blueprint is 3 inches long. How long is the actual room? So whenever I do these, if it's different units, I put my ratio on one side, 1 inch to 4 feet, 1 inch over 4 feet. And then when I set up my other side, I'm looking at what dimension do I actually have. So I am given this in inches, so that tells me that I'm going to have 3 inches on the top. And then I don't know how long the actual bedroom is because that's going to be measured in feet. So because I don't actually know how long it is, I'm just going to put an X. Okay? And then when we cross multiply, we get that X equals 12 feet. Now, if you have to cross multiply and it's not just a simple X equals whatever, just make sure that your final answer is the same unit as what would go with that X. So since I had X feet, my answer is going to be 12 feet. And don't try and worry about putting the units into the actual, like when you cross multiply, don't worry about the units too much. Just bring them back in at the end. So anytime you have a scale factor or a scale drawing, put the scale as one fraction of your proportion equal to the ratio of what you were given to what you are trying to make scaled. That is it for 7.5. If you have questions, you can post it in the comments below or actually talk to me in person. I hope this video was helpful. Let me know if I need to clear anything up.